Good afternoon, everyone. My name is Lucian Pullen, and today I will be doing a tutorial on angular momentum in torque and static equilibrium, as is said there in the highlight of this quiz. Okay, now some of these problems don't belong in this quiz, so I've specifically designed this so that you can understand angular momentum and torque. Okay, now let's start with a summary of angular momentum. Now, before you can even begin to study angular momentum, you need to know about the vector product. Okay, giving about the vector product. So let's start. What is a vector product? Vector product. Okay, so let's say we have two vectors, A cross with B. That's a vector product. It is a vector C. Okay, vector A cross with vector B is equal to another vector called vector C. Now, how do we get the magnitude of C? Remember, this should also be a vector. C is also a vector. Now, the magnitude of vector C is equal to, let me just see if it's broadcasting correctly. The magnitude of vector C is equal to the product of A times B times the sine of theta, where theta is the angle between vectors A and B. Okay, and that will give you the magnitude of vector C. But that is not done. Since this is a vector product, C is also a vector. Okay, the direction of vector C is perpendicular to the plane formed by these two vectors. Okay, the direction of vector C is perpendicular to these two vectors, to the plane that forms these vectors. Let's say vector A is pointing in that direction and the vector B is pointing in this direction. That's vector A, that's vector B. Then vector C would be in the plane perpendicular to both, will be perpendicular. The direction of vector C will be perpendicular to the plane. That is the plane of vector A and B, and then vector C will be perpendicular to that plane. Okay, the direction of vector C. I hope that makes sense. Now let's get down to what is actually needed. Okay, two main things. Okay, this we've already done a vector product. So angular momentum. What is angular momentum? Angular. Oh, let me try and write a bit better. Angular momentum. Angular momentum. Now, angular momentum is denoted by an Ly. I do not know, and it is the vector product of the position of the particle times its linear momentum. Okay? And we already know that linear momentum is equal to mass times the velocity. Okay, so that is the vector product of angular. Well, this is how you calculate angular momentum. Okay, r is the vector position from the origin relative to the origin. Okay, so angular momentum is the relative position of the particle relative to the origin, the vector that this particle makes, with relative to the origin, its position relative to the origin, crossed with the momentum of that particle. Okay, so that is angular momentum. Now, and of course, the angular momentum will be perpendicular to the plane of these two vectors. Now, what is torque? Okay, torque. Oh, another thing about angular momentum that I just want to the z component of angular momentum of a rigid body. Okay, the z component of angular momentum of a rigid body, or just the component of angular momentum. Let's just say in this case, it's the z component is equal to I, the moment of inertia, multiplied by W. I call this W, the Greek letter W. Its angular speed. So its moment of inertia calculated by its angular speed gives us its, in this case, if it's rotating about a fixed z-axis, this will give us its component. Now it can also be the component for the x and the y. Okay. Now torque. What is torque? Okay. Most of you guys and ladies who are into cars will see in the specifications the amount of torque that a car has. So we'll have tau. The torque is equal to its position is then a dot product, a cross product, a vector product with its force, right? So it's force around a angle. So that's the torque. So that is all that we have for the summary. We don't need any more. Let's now, for problem number one, I'm going to give you a vector product. Let's say we have M. This is problem number one. We have M and N. M is the vector 2i hat, 2i hat minus 3j hat and plus k hat. This is the vector. We are just going to deal with vector products. So you know how to calculate a vector product. Now we have N, which is 4i hat. I'm doing this one problem on vector product just to brush up on what you guys know on or should know about vector products, and minus 2k hat. So here we have two vectors, and the question is find the vector product M cross with N. That is the question. Okay, we want to find the vector product. And this is mostly how you will be given these type of problems. So we want to find the vector product. I just want to see quickly. Okay, so M, the vector product of M with N. Okay, let me erase that. So first of all, you need to set up the determinant. Okay, the determinant. Okay, so first of all, which vectors up front? First you write I hat, j hat, cos, k hat. Okay, then you write vector number one. The first vector is 2, the units in front of that vector, well, the numbers in front of the vector, I hat, j hat, and k hat, and so forth. That's 1, so it's negative 2, that's 2, negative 3, and 1. Okay, and here we have 4, 5, and negative 2, so it will be 4, 5, and negative 2. Now you have all done determinants before, so I will not insult you by doing it step by step, but maybe I should. So for the first one, we have negative 3 and 1, 5 and negative 2, and that is I hat. Then we have negative j hat, negative. There is a rule in math, I forgot what it is. So in your first year, you have 2. Of course, you cancel those two, that's 2 and 1. There's 4 and negative 2. And this is j hat. And then finally, let me just see if it's still showing. Everything is showing up. Okay, we have plus this determinant, and that's k hat, of course. Okay, it fits just barely. K hat of that, that's 2, -3, and then here we have 2, -3, and 4 and 5. Not 45, 4 this side, 5 that side. 4 is too big, 4, and then 5 there. Okay, so there we have our determinant for this cross product that we want to do. Remember, I'm only asking you, there's no momentum or whatever that needs to be calculated now. At this point, I'm just teaching you how to do a simple vector product. Now, if we move on to our vector product, we found the following. We should find it is if we calculate the I hat component, this is the I hat component, then we have that's positive I hat component, negative j hat component, and then positive k hat component. Okay, so that is the determinant for the first one. If you remember, it's -6. It's -3 multiplied by -2, it's 6. So it is 6 minus 5. The next one is the negative, of course, in front, and we have -4 minus 4. You can check these determinants yourself. You should be fine with working out determinants, and then that should not be there. Let me write it here, plus 10 plus 12. You can go and make sure that is equal to m cross n. Okay, so m crossed with n is then equal to 6 minus 5 is 1 I hat, which we normally don't write the 1, but I'll write it in this case. Then it is -8 of negative, and then it is +8 j hat, and then 22 k hat. So that is your determinant. So the vector product is 1 I hat. Sorry, this is not a j hat, this is an I hat. This is I hat. 1 I hat plus 8 j hat plus 22 k hat. Okay? That is the vector product. That is how easy you do vector products. Just purely by doing the determinant or calculating the determinant. Okay. Now let's go to a problem actually involving angular momentum and the vector product. Okay. Let's say we need to find the angular momentum of a problem. 2, we need to find the angular momentum. What we want is the angular momentum. They give us R. This is a problem in Subway and Jewett. Okay, they give us the R. Let me just make sure about my specific problem. Yes, you are given, this is problem number 12 in the 9th edition of Subway and Jewett. They give you that we have a 1.5 kilogram particle. You need to find the linear momentum. Let me just tell you what has been given. M, the mass, is 1.5 kilograms. This is all that's been given. The position vector R is equal to 1.5 I hat. I keep trying to write a j hat here. I hat plus 2.2 j hat. That is the R vector, the position vector, and then we also have the velocity. Okay, note that they gave us the velocity instead of the momentum, but You have been given mass, so you can calculate that is the position vector, that is in meters, of course, and this is in meters per second. Okay, so we have been given mass, velocity, position. Okay, so how do we calculate the angular momentum? How do we calculate angular momentum? Let's look at it. Angular momentum, like we said earlier on, is equal to r, the position vector, crossed with the linear momentum. Okay, and another way of writing that is just the mass multiplied by r crossed with v, the velocity. Now we can compute this cross product. Okay, let's calculate the cross product first, r cross v. Okay, let's calculate r cross v. So r crossed with v, I hope you note this down. Let's first calculate r cross v, and then we'll multiply the mass in, and that will give us the angular momentum. Okay, so r crossed with v, the position crossed with velocity. Okay, we'll use the determinant method. We have I and j, and here we have, of course, we have the vector for r. What is r? Let me just make sure. Where's the problem? Yeah, there we have it. R is, the position vector is 1.5 and 2.2, the j component, and then the velocity is 4.2 and 3.6, negative 3.6. Okay, so first we find that vector product. So that this is equal to, oh, by the way, what I did not say is that this whole answer will be in the k-hat direction. Of course, the vector will be in the k-hat direction. So it will be 1.5 times 3.6 times negative 3.6, 1.5 times negative 3.6 minus 2.2 times 4.2. This is just simply determining the determinant. That gives us an answer of negative 5.4 minus 9.24 in the k-hat direction, which gives us negative 14.64 in the k-hat direction. That is the product of r, the vector product of the position vector and the velocity. Now, in order to get the L, the angular momentum, you need to multiply Rm by R cross V. Okay, then you will get the angular momentum. So 1.5 multiplied by negative 14.64 in the k-hat direction will give us an angular momentum in the k-hat direction of approximately 21.96 in the k-hat direction. That is the angular momentum. So That is the angular momentum. So we've learned how to calculate angular momentum based off the relative position and of course the velocity. Okay, so now we are more or less cool with angular momentum and vector products. So question number one here then, if we are to go to question number one, a light rigid rod of length L is equal to 1 meter. Let me just draw the situation. Or it is, this is question one. I want to draw the situation. We have this here. This is the situation. So we have a rigid rod of length 1 meter. This is, it's turning in that direction, and this one is going in this direction. This is M2. This is M1. This is a velocity V. That's the velocity V. That direction. Okay. So a rigid rod of length L 1 meter joins two particles with masses M1 is 4 kilogram. So this one is 4 kilogram, and the other one is 3 kilograms. So this one is M1 is 4 kilograms. So I'll write is 4 there. Oh, let me rather not. So this is 4. I'll write the 4 in a different color inside the block. So this one is 4 kilograms, and that one is 3 kilograms. So we have this situation, and this block is spinning, or rather, why do I keep saying block? This rigid combination. So this combination rotates in the XY plane about a pivot at the center of the rod. So it's spinning like this, it's going around. Determine the angular momentum of the system about the origin, where the speed of each particle is 5 meters per second. So the speed is 5 meters per second. Now let's take the geometric center of this compound. Okay, so halfway through, zero point 0.5 meters, here's the geometric center like they told us. Okay, so if we take that to be the pivot, okay, or the point about which it turns, we can say the following: the angular velocity, the angular speed, so not say velocity, is equal to the velocity divided by r, the radius. Okay, so the velocity they told us is 5 meters per second. There they told us the when the speed of each of the particles is 5 meters per second, and of course the radius in this case is 0.5 meters, okay, of this closed system. So the angular speed therefore is equal to 10 radians per second. So you should have known how to calculate this. So now you have the angular speed. Now you know that moment of inertia, okay, the moment of inertia, you have the angular speed. Let's continue on this side. Let me see if there's space. Okay, there's space. I don't want to erase that. So you know that moment of inertia for any substance, remember, is the sum of the mass times r squared for all of them. Since there are only two particles in this case, in this system, we only have two. So it is one has a mass of 4 kilogram and its radius zero point 0.5, and then you square that, and then you add the other has a mass of 3, and let me just write it here, plus other has a mass of 3 and a radius also of zero point 0.5, which is also squared. Therefore, the moment of inertia, which we want to calculate, therefore is 1.75 kilograms meter squared. That's the moment of inertia. Okay, so we have the moment of inertia. I. Remember earlier I told you that we could also calculate angular momentum as the moment of inertia multiplied by the angular speed. We already calculated the angular speed and the moment of inertia. So the moment of inertia we just calculated 1.75 kilogram meter squared, and then of course the angular speed earlier on was 10 radians per second. So the angular momentum therefore will be in the k hat direction. In this case, if you choose to look at it that way, will be 17.5 kilograms meters per second, meters squared per second. And in this case, I'm choosing k hat direction. If we say that those two are operating in the xy plane, then the angular momentum would be perpendicular to the xy plane, which is the z plane, or the z direction, which is the k hat direction. Okay, so we have calculated the angular momentum. Okay, question number two. Question number two. Let me just look at it. I'm wondering if I should do another problem on angular momentum, or should I continue with torque? I have substituted those two problems that does not belong there. They do not belong there. Okay, let's do until question number three. Okay, there should be enough to work with. Okay, find the mass of a counterweight. I want to show you this problem. There's a picture. Okay, there's the picture. I just want to enlarge it. I want to show you the picture, and then maybe show you what I am seeing here. So the problem is find the mass of the counterweight needed to balance a truck with a mass of 1.5 kilogram on an incline of 45 degrees. See the figure. Assume both of the pulleys are frictionless and massless. And they give us the answer should be 177 kilograms. Okay, so let me just try and show you what I am looking at. Where is it now? So Jewett. Okay, that is the problem there. Okay, just ignore everything else. I just want you to look at the image. So we have that image there. I just want to enlarge it quickly, or rather make it smaller. It fits there. Okay, so there's the image that we are looking at. This truck being held by this pulley system. Where is the zoom button? Okay, there we go. So this is the situation. Let me just show you the question as well. Find the mass of the counterweight M needed to balance a truck with a mass of 1,500 kilograms on an incline of 45 degrees. Okay, so we need to find a mass of M that would keep that truck stationary. Okay, at the moment, if mass of M is 0, the truck will begin to slide down due to gravity. Okay, now there are two conditions for equilibrium. Okay, all the forces must be equal to 0. The sum of all the forces must be equal to 0, and the sum of all the torques must be equal to 0. Those are the two conditions for equilibrium. Now the second condition for equilibrium Says the sum of the torques must be equal to 0. Okay. So if the sum, so on the second condition, if the sum of all the torques is equal to 0, and we calculate the torque for each one of them. For mass M, the torque would be, first of all, the truck would have a torque, and the the truck would have a torque, and the mass would have a torque. Okay, so they should both be equal to 0. Now, the torque of the mass would be the weight of that mass. It will be mg, the weight of the mass, multiplied by the distance that it acts at. It's 3r, so times 3r. So that's the torque of the mass, of that mass of block M. Okay, and then you subtract on the opposite direction. So this is the clockwise torque. So the counterclockwise torque would be negative, and that would be the mass of the truck, big M, multiplied by the radius. In this case, is just r, small r. Okay. Or rather, in this case, not the mass of the truck, just look at not the mass, there's a mistake here. So, not the mass exactly, but the tension in that line. Okay, so the tension that the truck causes. Okay, so first of all, then we need to calculate just the tension then. So, this is the formula for the sum of the torques. This is for the block M, too big. This is for block M, and this is for big block, big M. Okay? The tension times the radius is the counterclockwise torque. So now we need to calculate T, the tension. Okay. Now the truck is also in equilibrium, so that means the sum of the forces must be equal to 0. That means, remember that pulley is W rep, so 2 times the tension minus the mass of the truck, the weight of the truck rather, times the sine of 45, in this case, sine of theta, 45, should be equal to 0 because the truck is stationary. The tension is holding it up while the weight at an angle is pulling it down. This is your basic mechanics from last term. So therefore, T, the tension, is equal to the mass times gravitational acceleration times the sine of 45 divided by 2, because the tension is double. Okay, it's halved by the doubling of the string. So if I plug in everything, the mass of the car or the truck is 1500, gravitation is 9,81, and then the sine of 45 all over 2 gives me the tension is 530 newtons. So the tension in that rope holding the truck stable is 530 newtons. Okay. So actually not 530, it's 530 G. So 530 multiplied by 9. I just want to do quick because I did not multiply that in. Let's just see 530 G. Or let me rather not write it. I'll write it this way like I did here because I cancel G again somewhere later on. So 9,81 multiplied by the sine of 45. Okay, I'm not supposed to write 9, I'll just write G here. G. and then the sine of 45 degrees over 2. Okay, so the answer will still have a G in, so it's 530 G newtons. Okay, that is a G. Do not, that's not grams, that is the gravitational acceleration G. Okay, so remember now, we require the, we've already got to have the tension now, so we require M. So what we know from our previous example is that M, small m times G times 3R is equal to minus the tension times R. That's equal to 0. Remember our original sum of the torques is equal to the sum of the torques. Okay? That's our original formula, but we have found T now. We want M. So mg 3R is equal to the tension times R. We've already determined that the tension is 530 times G times R, and that is M times G times 3R. We could cancel R and G, R and G. So 3M is equal to 530 newtons. G and R is cancelled, so let's use that. Would be newtons. So it's 3M plus 530. So M is equal to 530 divided by 3, which is 177 kilograms. And that, ladies and gentlemen, is what you should get. That's the amount of mass required to hold that truck stationary. Okay? Last problem for today. 3. Problem 3. It has to do with torque. Okay? Torque. And I want to show the actual, I want to see if I can show you not the problem, but the actual drawing or the illustration of the problem. I think I want to show you a hungry bear. This is problem number 3 now. A hungry bear weighing 700 newtons walks on a beam in an attempt to retrieve a basket of goodies hanging at the end of the beam. The beam is uniform, weighs 200 newtons, and is 6 meters long and is supported by a wire at an angle of 60 degrees. The basket weighs 80 newtons. They ask us first, show a force diagram of the situation. But first I want to show you the situation itself. I think I have the problem with the illustration. I'm looking for the illustration with the bear. I want to see, did I miss it now? Where is the exact, I'm looking for the exact problem now on torque. I do have a picture here, but I'm wondering if it is actually, okay. Let me just draw. That's why they ask us to draw the force diagram. Okay. I assume that there is no. So let's look at all the info given. Doesn't look like there is a. A drawing to support this question. Okay, so we'll need to draw it for ourselves. So we have, oh, it shows, let me see, 12.4. Oh, here it is. I found it. That's the problem. Let me just show it. Okay, so there's the problem. So, a hunting bear weighing 700 newtons, so there's the bear, walks out on a beam in an attempt to retrieve a basket of goodies hanging at the end of the beam. So there's the situation. I wanted to show you the drawing. Now, the question. They tell us the bear weighs, the beam is uniform, it weighs 200 newtons and is 6 meters long, and it is supported by a wire at an angle of 60 degrees. The basket weighs 80 newtons. Now, let me draw, they ask us to draw a force diagram for the beam. So this is the beam. Force diagram helps incredibly when dealing, this is the origin, okay? The point where it's connected to the wall. So there we have, let me write the origin rather here. This is the origin. O for origin. So we have the beam is 200 newtons. So the beam, mostly we usually assume all the weight is at the center. So 200 newtons of force going downwards. That is the weight of the beam itself. The bear, it makes an angle. There is an angle of 60 degrees. The bear walks along this beam, and this bear walks a distance of x, and the bear has a weight of 700 newtons. Okay? That x will vary, so which means that 700 newtons will move along the beam. This 200 newtons is exactly at the center of the beam. And then of course, the basket at the end weighs 80 newtons. And that is all. And that is the origin, of course. There. Oh, it's there. Let me rather erase that. Okay. So here we have three forces acting on this beam. Four, of course, with the tension holding everything together. Rx, Ry, of course. Now we have the force diagram. Now we calculate. What did I ask first of all to calculate? First they ask us to calculate, check, draw the force diagram, yes, and then B, When the bear is at x is equal to 1 meter, find the tension in the wire supporting the beam and the components of the force exerted by the wall on the left end of the beam. Okay, so first we need to find the tension in the wire supporting the beam, the bear. Okay, let me just go back to the actual question so you guys know where I am. Okay, so we've drawn the force diagram. There it is. That's 60 degrees. When the bear is at x is equal to 1 meter, so when it's at 1 meter, find the tension in the wire T supporting the beam and the components of the force exerted by the wall on the left end of the beam. That's the components there. Okay, so x is at 1 meter, so the sum of the torques around the origin is equal to, first of all, those three forces, 700 newtons multiplied by, it's a distance of 1 meter. Of course, they're all going down, so it's -7 plus, we have -200 times 3 meters plus, that's -80 force going downwards, and that's at 6 meters, okay? And then plus the torque is going in the opposite direction, so is at, the torque is just a component of the torque, it's not vertical, so we need to calculate the vertical component of the torque there. The perpendicular component of the torque will be B. We just erase that. The vertical component of the torque will be the sine of 60 degrees. That will be 60, so that will be opposite sign. So if you want to calculate that component there, the vertical component, perpendicular component of the tension, it will be T sine 60 multiplied by, and it's acting at a distance of 6 meters too. So you have everything. The sum of the torques must be 0. So you have everything that you need to calculate the tension. Okay, you put everything on one side, solving for the tension. Okay, that's 700, that is -600, that is 80 minus times 6, that you find sum all of that, take it to the other side, divided by 6 times the sine of 60, you get that the tension is equal to 343 newtons. That is basic math. Algebra, you just need to work it out for yourself, or just rather just make T the subject of the formula and solve for it. That is high school grade 10 math. So you have that the tension is, they ask us, find the tension in the wire supporting the beam, and we have the tension and the components of the force exerted by the wall on the left and the right of the beam. Okay, so we have the tension. Now Rx, the x component of that force, rotational force, is equal to the tension times the cosine of 60, and that is just equal to 171. We have the tension, well, not the detension, the tension is 343, so Rx is, that component is 171 newtons, and Ry will just be the sign there, which we already have. Ry will just be 980 newtons minus the tension force. This is all the forces there minus the tension force. Therefore, Ry equal to 683 newtons. This here, this was 980, okay, is the force of all the weights going downwards. So it's 700 plus 600, no, 700 plus 200 is 900 plus the 80, that's 980 going downwards, and then of course the perpendicular tension going upwards, and that is the sum of the forces, which means this is just going downwards because we chose downwards as positive here. And then number three, what is the question three? If the wire can withstand a maximum tension of 900 newtons, what is the maximum distance the bear can walk before the wire breaks? So we need to find x before. So if T is 900, so we need to make the tension if. So let's make the tension 900. If T is equal to 900, what is x? You need to find out what x is. Okay, how far can the bear walk? So you do it again. The sum of all the torques is equal to negative 700. This is the bear x minus this plus minus 200 of the beam. That's at 3. Then it's minus 80 plus minus 80. I'm taking upwards as positive now, times 6, and then positive actually 900, because the tension, the max tension is 900, times the sine of 60 times it's acting at 6 meters. So we need to find out x, and that should all be equal to 0. So if you work out for x is equal to 5,14 meters, then the tension will be 900 exactly in the row. But if that bear steps a single millimeter over 514 meters, that beam, that rope will snap, and the bear will fall with the goodies. So that, ladies and gentlemen, is all that we have time for today. I did say that these other problems do not belong there. These problems belong in practice course number 6. They are on oscillic harmonic oscillators. Okay, so those are the three. I did substitute two more, and I would like to say thank you for listening, and I hope this helps you in some way.